everybody. We're going to spend a little bit of time talking about gas laws, a little bit more in depth, and there's two particular subjects that we need to get into, and that's diffusion and effusion. So this video we're going to talk about diffusion and all of those things that diffusion is and does. So let me get rid of my face here. That's strange. Okay, let's move forward, and this is really the only slide I have on diffusion. Okay, and so diffusion has to do with the motion of molecules, and so one of the things we should know is that molecules are in constant motion. Okay, motion of molecules is related to its kinetic energy. Okay, and kinetic energy is then related to its temperature. So when we take the temperature of something, or when we find the temperature of something, we're really trying to find out how fast things are moving. Okay, and so what diffusion is, and in real life terms what it is the reason why you can smell cookies when they're being baked throughout the house is because given time, as the cookies are being baked, the gases that are being given off in the cookies, and I know that sounds weird, but that's what we're smelling. We're smelling the particles of gas being given off by the cookies. Okay, those are filling up the house and then filling them up evenly. Okay, so given any amount of time, the mixture will mix completely so that it is, so that there's not one side that's completely cookie-like and then another side that doesn't smell like cookies. Okay. And so why is it that after time you don't smell cookies at all? Well, eventually, again, given time, it will diffuse to the atmosphere, outside the atmosphere. Okay, and then eventually there will be such a small amount of cookie particles that you just won't be able to smell them. So that's kind of neat. Okay, and so if you have light molecules, and whenever we talk about light, okay, or heavy, what we're talking about is the molar mass. Okay, that's the easiest way to determine light and heavy. Okay, but so light molecules will diffuse fast. Molecules that are small will be able to fill container and spread out evenly more quickly than heavy molecules, and I think that that makes sense. Only because there's one slide, I'm gonna show you why that is. Okay, so kinetic energy is equal to 1/2 mv squared. Okay, now you don't necessarily need to know this, but what we can see is that mass, m is here, this is mass, and this is velocity. Okay, so that's the motion of the molecules. But if we're at the same temperature, okay, so that means the same temperature. So if we have a light molecule, so the molecule is small, in order to count for it, this velocity has to get quicker, and so a quicker velocity means that the molecules are going to fill the air more quickly. Okay, and then the opposite is true. Okay, when we look at this formula, and I'll do this one in red, when the mass gets bigger, so now we're dealing with heavy molecules, in order to keep the temperature the same, the velocity has to decrease. And so, and I know that there's halves and squares and stuff in there, but the relationship is still when one goes up, the other one goes down, and so that means that bigger molecules are going to move slower, then they're going to diffuse. But eventually, over given enough time, everything will diffuse. Okay, so that is what diffusion is, and I hope you have a great day.